computer. So we begin our journey with machine learning. You can, of course, I know how resourceful you are. You can look at several sites that explains what machine learning is. There's one good site developed by SAS, and it basically teaches us some important notes about machine learning. So let me just go through this very quickly. In this SAS is a software, okay, and then in fact it's one of the softwares that we are supposed to use, yung analytics via, which we're going to learn hopefully before the end of the term, because our goal is to do Python, of course R, Python, and analytics via, okay, which is developed by SAS. Okay, so as the name is described here, it's a method. Machine ML is a method, and it's a method that's used in data analysis. And the good thing about ML is that it automates analytical model building. So branch siya ng AI, no? Branch siya ng artificial intelligence. And AI is actually based on the idea that systems can learn from data, identify patterns, and then make decisions. So this is something that's really very let's say descriptive, no? So AI daw ang sabi, it tells us that systems can learn from data, identify patterns, and make decisions. So that's what we're going to do in machine learning. We're going to use data, and we will ask the ML tool to identify patterns and make decisions for our purposes. Okay, so there's this evolution. I'm not going to read through this, but the applications of ML are really far reaching. No? For example, yung self-driving Google car, ML yung ginamit nun, guys. Machine learning yun. Okay, do you watch let's say YouTube Premium or Netflix? Si Netflix nagbibigay siya ng recommendation based on what you have been watching. Okay, so ML din yung ginagamit yan. So many things sa finance, fraud detection, banks or financial institutions make use of ML in order to protect their customers. Okay, so I'd like to encourage you. Okay, ilagay ko nga itong ano na to, itong this HTML, control C, share ko guys sa chat natin. Okay, so that you can bookmark this so that you have an access to this. Okay, you can watch this video, short video lang naman yan. Okay, and then it tells us why machine learning is very important. Okay, we won't read through this, guys. I will assume that you know how to read, of course. And then here are some descriptions and some papers on machine learning in business. Okay, the importance of learning machine learning, ML, and then the application of ML on the Internet of Things. So very good materials here in this site. Okay, so sino daw gumagamit ng machine ML? As I mentioned a while ago, financial services, government, healthcare, retail, of course, big companies, big industries like oil and gas and transportation. Okay, so here are some descriptions on how, for example, sa banking, sa finance, ano? Banking, capital markets, kung paano ginagamit itong technology, itong ML sa specific industries na to. Okay, medyo mabagal lang access yung ano. So okay, so I'll let you guys read on this on your own. So I hope you do that, no? So some information about how industries, including those that deal with finance, make use of ML or machine learning, okay, to further or to meet certain objectives. Now, there are different types of ML methods. Meron tayong supervised, unsupervised, semi-supervised, and reinforced learning. The focus will be on supervised learning, although we will have an example of some unsupervised learning. Pero itong semi-supervised at saka reinforcement learning, we will not tackle this. No? Okay, so there are some examples here. Kunyari, regression, guys. No? Regression is a type of supervised learning. So what you learned in your FinStar, maybe before, guys, pwede natin gamitin yung machine learning dyan. So instead of using in R, the usual function LM or the GLM, we can make use of machine ML tools to develop regression models. So for example, guys, supervised learning, andyan yung classification. Classification example yan, di ba, logistic regression, to determine whether, for example, kunyari ano tayo, yung health insurance. Tapos based on certain parameters, kunyari yung lifestyle ng tao, age niya, weight, height, etc., we will be able to determine kung prone itong taong to for sickness or dapat ba natin siyang tanggapin or bigyan ng health insurance. Or if tatanggapin siya, how should we now do the premium? So magkaka-premium pricing ba yan kasi at risk yung taong yan, etc. So that's part of classification or regression, of course prediction, and then we'll go into gradient boosting then. Itong interesting itong gradient boosting kasi napaka-powerful itong mga tools na to. Okay, so for example, ML allows us to anticipate when credit card transactions are likely to be fraudulent or which insurance customer is likely to file a claim. So these are just examples of applications where you can use ML in supervised learning. Of course, meron din guys na unsupervised learning. So dito, titingnan natin yung mga nearest neighbor, K-means, clustering, etc. So these are also topics that we're going to dabble with. All right? So ano yung mga examples sa mga tools dito? Okay, so yan guys. Ito yung mga sample ng tools. Meron tayong NN, yung neural networks. Decision trees, ito yung unang titingnan natin. Random forest also. We're also going, yan sabi ko kanina yung gradient boosting and bagging. SVM also, we're going to look into it. Okay, nearest neighbor, this is unsupervised, K-means also. Okay, although hindi natin titingnan yung iba, yung Bayesian that will not depart kasi kulang na kulang tayo ng oras, no? Okay, so we have a lot in our hands and you'll be glad guys that we did this kasi ang ganda talaga ng topic na to, no? And as finance analysts or finance students or finance professionals later on, it's imperative that we have a knowledge of what ML is all about. Maybe in your research, guys, in your recipe or in your research 1 or research 2, maybe you can use the topics here, you can use the methodologies here. Okay, pwede nyo gamitin yon later on. Eh, hindi pa masyadong ginagamit yan kasi usually panay regression, panay panel regression, and maybe you can compare yung output ng isang ML method versus a classical regression method. These things, you can think about these things. All right, so I leave that guys now. Let's open the R file that I shared with you. Okay, so ang unang kukunin natin, sandali lang ha. I'll just save yung kaninang lesson namin, baka mawala to. Okay, file. Okay, file, save as. Okay, this was our FinStar lesson a while ago. Dali lang guys ha. Okay, FinStar. Okay. Bagal talaga. Okay, so let me close this first. Okay. Save. Okay. Let me close the other files. Kasi bumabagal guys eh. Okay. Okay, this one. This one. Okay. This one. Okay, so that leaves okay, ito lang no. Decision tree natin. Ito yung unang ML method na gagamitin natin. Okay. So yung decision tree, guys, allows us, it's a modeling technique used in decision tree for us to model or to predict ano yung magiging outcome based on certain parameters. So this is used for prediction, and we have several variables. Parang regression siya, kaso mas powerful to, a lot powerful sa regression. Kasi we can use either character variables or qualitative variables and even quantitative variables na mas madali, no? Kaysa mag GLM or LM sa R. Okay? So we're going to make use of the package party. So may I invite you to install that first? So kailangan i-install nyo muna kasi hindi po nyo pa na-install yan. Para sa akin, since na-install ko na itong party package, no? Okay? So siguro tingnan natin dito. Okay, ano ba yung party package na to? Party. Okay, wait. Ito ba yung ano? Ito ba yung... Bili lang guys, ha? Okay, nada-download to. No? Okay, kasi minsan may mga packages na ano eh, na, okay? A laboratory for recursive partitioning. So this is used for partitioning. Okay. Of course, you can download the vignettes for this one. Okay. Description file, user guides. Pwede natin kunin yung user guides nito o yung documentation. Okay, saan na ba yung user guide nito? Anyway, guys, you can Google this, yung party package. So pakita ko lang, no? Okay, party package documentation. Okay, so this is a good practice, guys, where you download the documentation. Okay, or ito sa Quran. Okay. Yan. Party package, updated na siya. Latest update, September 27. Okay, version 1.3.9. Okay, so a computational toolbox for recursive partitioning. Recursive yung paulit-ulit, no? Pinapartition niya. So this is very good for classification and prediction. The core of the package is C3, okay? C3 yung pinaka-ano niya, main command, no? Okay, an implementation of conditional inference trees which embed three structured regression models. Okay, so this is good for regression into well-defined theory of conditional inference procedures. Okay, etc. So napakita dito kung sino yung kung sino nag-develop nito, etc. And these are the codes. Okay, codes that we may use for this package, for this party package. Okay. So I leave you guys to download this and to read through it. It's a good practice to read through the documentation, even if you don't understand everything. No? Pero minsan may mga examples kasi sila na which you can follow. You can, ito may mga examples ito. No? Okay, so these examples you can run in RStudio and try to see what this code does. Okay, so going back to our model, okay, I hope you have already na-access nyo na ba guys yung na-install nyo na si library package, library party package, sorry. And kindly chat yes na lang guys kung done na. Okay, thank you David. Thank you Santino. Okay, let's wait for the others. Jillian, salamat. Has said, okay. Thank you guys. Okay, good. Okay, so since we have installed it already and accessed it, required it, okay, let's now import the cardio data set that I gave you. So wherever you saved it, guys, you know how to import data set. You can use this, or you can use the read.csv. But For purposes of this, I'll just import it. Import dataset. And then na-save ko siya dito sa, okay, hanapin ko kung saan siya sinave. Tapos kayo din guys, hanapin nyo kung saan nyo siya sinave. FINANLY. Okay, and then decision tree, then cardio. Okay, so we're uploading the cardio dataset. Yan. So medyo maraming variables siya, no? Yung cardio dataset, guys, I'll explain in a while. This is more application sa medical, no? Okay, so in determining whether yung heart condition ng isang individual, we'll explain that yung NSP. So import natin. Okay, and then you can actually copy this. Ito, no? Ito, I'll just copy this code here in the console natin. Okay. Makakatulong din yan guys para for you to know how was this data uploaded. So it's a read.csv file. Okay, so it came from itong site na to, itong folder na to sa ano ko sa computer ko. And then view natin yung cardio. Okay, so I'll just provide guys, hindi ko pa pala na-provide to, no? It's always important to get the metadata of the data. Kasi paano natin maiintindihan yung model natin kung hindi natin alam kung anong ibig sabihin itong models na to. So, pardon for this, kasi medyo, ano siya, medyo medical, no? I'll just send this to you. Dali. Okay, kanina pa talaga naglolo ko itong computer ko. My apologies. Okay. So what is this dataset all about? So it's a cardio medical, no? Cardio sa heart topographic data. Okay, so what's this all about? Sandali. Yes, Santino, what's your question?
Hi, sir. For the party packages and for some of the packages, it says now it requires version 4.05 po.
Sorry, again. It requires?
It says now it was built under version 4.05.
Okay lang yan. It's
okay. It will still work po, sir. It's just a warning.
Of course. Oo, of course.
It will still work. Okay.
Thank you for that question, Santino. Okay? Okay lang yan. Okay, minsan magkaka-problem lang yan kung may mga functions dun sa party package which will not work. Kasi minsan may kunyari, ano ba yung version natin ng R ngayon? I think 4.1, no? So even if hindi pa na-update yung party package niyan, even if it was created under 4.05, for example, may yung mga functionalities ng 4.1, it can still read yung functions ng party package. It doesn't matter. Minsan mas nagkakaproblema kung yung R natin is a lower version, no? Kunyari ang R na ginagamit natin 3.0. Tapos si party package 4.05. So that can result into a problem. Mas ganoon yung nagiging problema. So the solution there is to update your R Studio para mas kaya niyang mabasa or ma-recognize yung mga functions ng mga packages. All right? So these are just I'll just send this to you guys. Ano to mga definition ng mga variables, no? Okay, we won't go into this one so much kasi hindi naman tayo mga medical field practitioners. Pero what's important to us is this one. Okay? Fetal state class code. Okay, so ibig sabihin nito, so para sa no? Fetal movements per second. So this is data of pregnant women. So tinitingnan yung babies nila, tapos tinitingnan kung normal ba yon or suspect or may pathologic. Ibig sabihin baka may sakit, no? Okay, so I think that's what this data is all about. No? So my LB, which is beats per minute, yung heart, accelerations per second, fetal movements per second, etc. No? Okay, so anyway, ang gagawin lang natin, we'll just explore this data. Hindi naman natin gagamitin lahat. No? Kasi just to set the tone as an example for decision tree. No? As the name suggests, decision tree, guys, makikita natin na naggagawa nga talaga siya ng trees. No? Ng trees in order to analyze our data. Okay, so let's go back to our model. Okay, so we have accessed the data already. Okay, dyan na si Carjo, no? You have 22 variables of 2126 observations. So let me just highlight that. Okay, 2126 observations and then 22 variables. Okay. So ang pinaka-importante sa atin itong kulay, yung NSP, no? Yung 2, pag 2 guys, ibig sabihin yan that's suspect. Okay? N is normal, 2 is suspect, ito yung mga, and 3 is pathologic, no? Ibig sabihin may problema, no? Yung fetus. Okay, so N, normal, suspect, and pathologic. So that's what we mean by NSP. So ang gagawin natin guys dito, i-predict natin kung based on our observations, normal ba or suspect or pathologic yung yung fetus, no? Okay. So that's what we're going to do here. Guys, ano lang to, example lang to. And this highlights the fact that machine learning is not only used for numerical quantitative subjects like engineering or business or finance, ginagamit din to sa medical field. Okay? Data science or ML, guys, ang dami ng application yan in all fields. So this is just to appreciate that you can apply ML in several fields. Okay, let's go to decision tree now. Okay, so let's first take a look at the data, yung cardio data natin. Let's take a look at the structure. A structure gives us the variables and then kung anong klase sila, no? So it's a data frame. You know what a data frame is, guys? So you have rows and columns of data. Tapos yung bawat column may pangalan siya. Okay? And then pareho yung number ng variables natin, ng mga columns natin. So LB is integer, no? Okay, ito yung kaninang pinakita ko, LB. This is just to LB is the baseline, yung beats per minute, no? Beats per minute. Tapos yung accelerations per second at saka fetal movements per second. These are numeric. Numeric. Pati ibang variables, guys, merong numeric, may integer. Okay, and at the end, we have here yung NSP natin. Okay, integer siya. So binasa siya ni R read it as integer 2113. Although we don't want it to be an integer, later on we'll convert that because we want it to be a factor. Okay, if you recall, guys, I think I mentioned last time that a factor is a variable. It can be character or it can be numeric, which can be used as a classifier. So for classification. Okay, so si NSP, gagamitin natin as a classifier, normal if 1, suspect if 2, and pathologic if 3. Okay, so later on we will classify that. No? Okay, so structure and then summary, guys. Okay, we know what this generates in summary. So for the quantitative variables, it gives us the 6 number summaries: mean, median, and then you have the first quartile, second quartile, which is the median, and then the third quartile, minimum, maximum. Okay? So yung mga yung mga categorical variables. Okay, meron ba tayong categorical variables dito? Okay, wala, no? Walang categorical variables. Okay, let me see again the cardio data. Yes, no categorical variables. Okay, so lahat sila may measurement ng 6 numbers summaries. Okay, although yung NPS natin, okay, NPS, okay, minimum niya, maximum 3. Okay, so parang wala siya masyado meaning kasi nga factor talaga to. No? It's not really a quantitative variable. Okay, so I stated here that NSP is a categorical variable, and we are going to classify that into as a factor. Okay, so dito guys, how do we convert now si NSP as a factor? Here, we're going to create a new variable. Okay, so from the cardio object, $NSPF, so we're telling R to create a new variable, and then this variable is considered a factor as that factor cardio NSP. So we're creating a new variable here, ang pangalan niya NSPF, tapos it's converting yung NSP variable as a factor. So mapre-preserve pa rin guys yung NSP, ando dun pa rin siya. Okay? Kung gusto nyong mawala yung NSP guys, wag na kayong mag-create ng panibagong variable. Then you make this cardio $NSP. No? And then as factor, cardio NSP. That will convert yung NSP variable natin into a factor. But here, let's do this para ma-preserve natin yung NSP na variable. We're just going to convert yung NSP variable into a factor. Okay, and then let's take a look at the structure of cardio. Let's run this. Okay, so we now have ngayon 23 na yung variables natin. Tingnan nyo, no? Okay, same number of rows. Now, why did it become 23? Because we introduced this new variable NSPF. Okay, so it's different from NSP kasi si NSP integer. Ito ngayon yung factor. No? So, na-recognize ni R na tatlong levels yan kasi tatlong iba't ibang numbers 1, 2, 3. Okay, so 1 being normal, 2 being suspect, and 3 being pathologic. Now, if this was categorical, if these were values, kunyari, gender, o kunyari, frosh level, college level, kunyari, frosh, sophomore, junior, and graduating, kunyari ganon, then there will be 4 levels. Okay? And then it will be treated now as classifiers. No? So magagamit natin yan. Kunyari sa regression, magagamit natin siya in order to see the differences between the effect of these factors on your dependent variable. Okay? So review lang yun ng FINSAR, no? Okay, now sa machine learning guys, okay, we have 2126 observations. Now, we do not usually use everything, use all the data in order to model. Okay? Constant practice sa machine learning is partitioning your data. And what does partitioning your data mean? Pag sinabi natin partitioning your data, split natin yung data natin. One data set will be used for training. Imo-model natin yung data natin doon. Tapos another one for testing. Okay, so what does that mean? Pag nakuha na natin yung model, i-run natin yung remaining data natin, yung test data, on the model. Okay? Kasi unless you have a new set of data, guys, hindi maganda guys na ipapasok natin lahat ng observations natin dun sa model natin. Why guys? Why? Kasi ang mangyayari niyan, gagamitin ng tool natin lahat ng data natin, tapos mag-model siya. So magkakaroon tayo ng overfitting. Okay? Overfitting, ibig sabihin, ginamit natin lahat ng data natin. Whereas kung natin guys, ipapartition natin, matetest natin yung model natin if it will work on the partition data. So I hope you get that, no? So ipapartition natin, split natin yung data natin into a set training data and a testing data or validation data. Okay, so tingnan natin to guys. Now, so that we have the same partitioning, okay, I don't know if my students ko naaalala niyo yung set.seed, no? Si set.seed, ang ginagawa niyan, nagra-randomize siya, tapos pare-pareho tayong random numbers, no? Okay, so that will make sure that we have the same training data and validation data. Okay, so dito, we're creating an object called PD partition data, no? So this is to partition data. And then, sampling natin, isi-split natin yung data natin, okay, into 2, no? Okay, isa-sample natin. So this sample, And then, ilang sample? Dalawa. So we are going to split the data into 2. If you want 3, then dapat 3 ang ilagay nyo dyan. But we're going just to split our data into 2. Then we have to identify ilang rows ba yan, yung data natin. Okay, so we don't have to type 2126. No? Okay, we just use the nrow function. The nrow function tells us ito kung ilang number of rows yung data natin, yung object natin na cardio. Replace is equal to true. This has something to do with getting your data. Kasi ang mangyayari niyan, kukuha muna siya, kukuha ng data, okay? Parang nasa siya, parang nasa bag. So kukuha isa-isa. Pag replace is equal to true, ibabalik lang niya, no? Ibabalik lang niya yung data niya, tapos kukuha ulit. So pag replace is equal to true, pwede may repetition yan ng data. That's okay, guys. That's okay. And then the split will be probability C is equal to 0.8 and 0.2. So that's how we will split the data. 80% dun sa isa, tapos 20% dun sa pangalawa. So mas malaki yung population ng natin mas malaking population ng training data, okay, kaysa dun sa testing data natin. So let's run this, guys. Make sure na magkasama yung natin. Okay, let's run it. Okay, so may PD na tayo, no? Okay, click natin yung PD natin. Okay, so we now have this object PD. Click natin. Sige, view na lang siguro, no? Okay, view. Para mas bilis. PD. Okay, let's see what PD consists of. Right. So yan, guys. This is our PD data. Notice, guys, na 2,126 rows pa lang siya. Pero you notice, guys, that each one of them, each observation is given an ID. 1 at saka 2. Okay, 1 at saka 2. So, yung 1 natin, guys, yun yung unang set, no? Yun yung 80%. Yung 2, yun yung 20% na lang. So, anong nangyari dito, in-split niya yung sample natin, in-split niya yung object natin na cardio. Yung mga rows, kunyari, itong 2126, that's classified as 1. Itong row 2121, it's classified as belonging to the sample, the testing data. So dapat, guys, magkakapareho tayo niyan, ha? Paki-check na, yung number 5 nyo ba equal to 2? Kasi nag-set that seed tayo eh. So dapat pareho lang tayo niyan. Otherwise, kung hindi tayo nag-set that seed, guys, magkakaiba tayo ng partitioning. Okay, could you kindly chat please kung pare-pareho tayo ng partitioning? Si 5 ko number 2, ibig sabihin sa pangalawang group siya. Si 14 ko number 2. Si 16 ko number 2 siya. Okay, pareho ba? Guys, please chat please. Kung pare-pareho yung result natin ng splitting ng data. Or am I going too fast, guys? Isa pa lang nagre-reply. Sabihin nyo, guys, kung masyado akong mabilis, ha? Babalik ko lang dun sa natin, sa code, baka. Pero may code na kayo niyan, di ba? So, i-run nyo lang hanggang view. Okay, how about the rest, guys? Five pa lang. 5 pa lang ng yes. How about the others, guys? Nag-yes na may iba? Okay, I'm expecting mga 11 responses, guys, from you.
Yes, sir.
Okay, good. Thank you. Nag-yes na pala, no? Okay, may question lang si John. Mine just says po, sir, name PD. Okay. How do you change? Sir, how did you change it to a column po sa PD? Itong code na to, view, no? We wrote this function, view PD. Okay? So, binigay sa atin yung ano, di ba? Remember guys, yung view, okay, it gives us the data in as a data frame. Okay, dito pala PD. Dito sa RStudio natin. How did you, okay na ba? Peer, ano yung nangyari? Okay, mine just says name PD type integer 2126 value 11. Okay, John, ano nga, okay. Can you show your, dapat pala ginagawa ko kayong co-host lahat. Ano? Okay, John, could you share your screen please? Stop share muna. Okay lang ba, John? Para makita natin yung ano, yung problem ng sa code mo. Thank you, John. Pwede mo nang i-share yung screen mo kasi nakaka-host ka na rin. Okay, set that seed. Okay, i-run mo nga yung ano, yung okay, integer. Sandali Yung isang PD mo. Marami ka ng PD, ano? Okay, i-run mo nga muna yung ano, yung highlight mo yung first, yung row 39 and row 40.
3940, sir.
39 and 40. I-highlight mo muna yan.
Highlight then control enter, no, sir.
Highlight mo and then control enter. Okay, tingnan natin. PD is integer 1.
The same, sir.
Okay, and then, sige, i-view mo siya.
Still the same, sir.
Okay, i-click mo nga siya. Bakit nag-integer lang siya? I-click mo
Click
yung
the tab, no?
PD dyan, i-click mo nga. Kasi that means, ano siya, no? It's a vector. Ano, vector nga. Vector nga siya ng ano, ano mo nga, balik ka dun sa ano natin. I-class mo nga siya, class PD, below view. Tingnan natin kung anong class siya. Class, small silang. PD. So ano lang siya. Okay, hindi siya vector. Ano kayong mali dito? Tama naman yung code mo eh. Okay, sige, create tayo ng panibago. Gawin yung PD1. Sige, gawin mo muna. Dito na lang sa ano, dito sa console mo.
On the right, sir.
Sa right. Panibagong ano, line. Enter mo nga. RM PD. Tanggalin muna natin si PD, no? RM, open and close parenthesis. Okay, so mawawala si PD dyan. Wala na, no?
Yes,
Wala na si PD. I-run nga ulit natin. I'm wondering why.
I will click view again, no, sir.
PD, PD sample 2. Tama naman yung code mo, no? Okay, highlight mo ulit yung first, sige, set that seed ka muna. I-run mo muna yung set that seed. Yung line na yan. Okay, tapos si PD naman, i-run. Control enter mo.
Still the same, sir. But I was following the codes in partition data. It's the same.
Yeah, it's the same eh.
Maybe in the earlier parts. Or they're not connected.
Pareho daw kay ni Peer, ano?
Same case as peer, no?
Oo, wait Okay, sige, let me, hindi ko, I don't know why that's happening, no? Okay, sige, i-leave muna natin yan, ha? Okay, let's see if despite the fact that hindi siya naka-vector, let's see if it will work, no? Sige, tingnan muna natin, experiment muna natin. Tapos anyway, naka-record naman to, no? Tapos maybe kung hindi natin makuha kung bakit, maybe later on tingnan natin. Okay, so that we were just able. Okay lang ba?
What, sir? About, sir?
Okay lang ba na ituloy muna natin, no?
Okay lang, sir. Can
Sige, ha? Kasi as of now, hindi ko ma-determine kung bakit hindi niya. Okay, dali. So ako na muna, no?
Yeah.
Ako na muna mag-share ng screen.
Yes, sir. I'll stop sharing, sir.
Sige, stop share mo muna. Okay. So sorry about that, hindi ko ma-determine kung bakit, no? Kasi so integer din naman siya, no? Pero if we take the class PD, it's a vector of it's a vector of integers. Ganun din naman sa'yo. Kaso I'm wondering why yung view niya hindi niya pinapakita, no? Hindi niya pinapakita yung yung itong vector na to. It should be a vector of integers. Pero let's see. Tuloy muna natin, ha. Let's see what will happen. So hindi po ba mali kami ng pag-import ng cardio? Okay? I don't think so kasi tama na-access niyo yung di ba? Nung nag-summary tayo ng cardio. Okay? I saw kay Jan nakita ko to eh. Ibig sabihin na import niya properly yung cardio. Tapos ginamit natin sa cardio kasi dun sa number of rows. Kung mali yung pag-import natin, then mag-e-error dito, no? Mag-e-error dito. Okay, so ganito muna, ganito muna. Let's see if this will still run. I hope it still runs, no? So what are we doing here? We're creating an object. Ang tawag natin sa object na to train. So this will be our training data. Ito yung gagamitin natin sa model natin, no? And then ano yung train na yan? So from the cardio, no? Cardio, ang gagawin natin lahat ng PD is equal to 1 at saka lahat ng rows. Okay? So sa cardio guys daw ang mangyayari sa subset natin PD is equal to 1, di ba? Ito yung PD is equal to 1, di ba? Yan, 1 1 1 1 1. So lahat ng 1, yun ang kukunin niya dun sa cardio na dataset. Okay, so ibig sabihin ng observation 1 hanggang 4, yung 5 hindi kasama yan. Then observation 6 hanggang 13 kasama dun sa magiging kasama dun sa train data natin. Tapos dito naman we're creating another object, ang tawag natin diyan test or validate. So gagamitin din natin si cardio, isa-subset natin si cardio with gamit natin yung PD na vector is equal to 2. So lahat ng mga 2 dito kay PD, okay? Yun ang mga isasama natin kay validate data, and it will include all the columns. Okay? So let's run this first, yung train, and then meron siya no, may open and close parenthesis, ibig sabihin ipiprint yan, control enter. Okay. Okay, John and Pierre, nag-run ba sa inyo?
Yes po, sir.
Okay, good. Ibig sabihin, okay lang na hindi niya generate yung, hindi ko lang alam kung bakit hindi generate itong data frame na to, no? But what's important is that, okay, itong train natin, take note, no? In-open and close parenthesis natin para i-print niya kagad. Okay, anong laman ng train? What's inside our train dataset? Take note, guys. 1, 2, 3, 4. Walang 5, no? Walang 5. Hindi niya sinama. Ano pa? 6, 2, hanggang 6 yata, 2, 6, 2, 4, 6, 2, 13. Hindi niya sinama si 14 kasi si 14 pupunta sa kabilang dataset yon. Okay? So clear to guys? Clear? Okay, so si train ilan daw? Si train is 1718 observations, no? 1718 observations. So if we check, okay, 1718, okay, 1718 divided by ilan yung ano? Ilan yung 2126, no? 2126, let's see. So that's yan, tagal ah. Okay, around 80%, di ba? Ito yung sinabi natin. So more or less, no? More or less, si train natin consists of 80% of the cardio data set natin. Okay, and then we move on. Yung validate naman, guys, run natin si validate, and it will only include those that were not part of your train. Kasi nanggaling sila sa PD, di ba? Di ba si PD, si partition yan, dinivide natin into 2, 1 at saka 2. No? So enter natin. Okay. So there you go. Ito ngayon si validate natin. Okay, nagra-run pa lang. No? Okay, yan. No? So 408 observations all in all. No? So 408 plus yung kanina, yung 1718, that will give us 2126. So hindi pa nagpiprint. Ayan na pala. No? So yan na. No? Yung 5, yung 14, etc. So medyo naghang yung aking ano. Huwag sana maghang kasi pag naghang, okay. Yan, okay. Alright, yan, guys. So what's not present in train dataset, pinasok niya kay validate. No? Okay, so what's good about this is that pwede nating i-model, okay, to predict yung NSP, yung normal ba o suspect o pathologic. I-model natin yung si train. Tapos i-check natin if that model will work sa validate. No? So ganun guys yung partitioning ng data. We will not use all the 2,126 rows, okay, coming from the object cardio kasi wala tayong additional na data. No? Okay, pwede natin sana malahat yung 2126 na yan kung meron tayong additional na data para matest natin yung yung model natin. Okay? So ang ginawa natin, in-split natin, okay, so that we will have, the assumption is that ang data natin, ang total data natin 2126 lang. Okay? Para hindi siya ma-overfit. Overfitting means ginamit natin lahat ng data natin in order to come up with a model. Alright. So okay na yung train natin, okay na yung validate natin. Pause muna ako guys. Any questions so far? Any questions so far, guys? Clear ba so far? Paki-chat na lang, please. Kung clear so far tayo. Okay, thank you. Okay, so kulang na lang ako ng dalawa. I hope guys, you're able to follow. Okay, so ready na tayo guys na mag-model tayo. Mag-model tayo ng decision tree. Okay, I'll show you in a while what a model decision tree looks like. So we'd like to create an object called Tree1. Okay, tapos ang ano natin, nakita natin kanina, di ba, nung sinearch natin si party, ang pinaka-importanting function dito yung classification tree, yung C3. Okay? So ang gagawin natin, i-model natin si NSPF, yung factor natin, not NSP. No? Kasi we want the factor NSPF. And then gamitin lang natin guys yung three variables, yung LB, AC, and FM. I leave you guys as an exercise na gamitin din yung ibang yung ibang variables in order to model our NSPF. So dito, gagamitin lang natin yung LB. Ano ba yung LB guys? Yung beats per minute yan, di ba? Yan. Heartbeats per minute. Yung AC is accelerations per second. And then FM, yung fetal movements per second. LB, AC, FM, yung first three variables. Okay? For your practice guys, pwede nyo isama yung mga other variables na to para makita nyo yung decision tree, no? Okay. So tatlo lang guys for purposes of example. And ang gagamitin natin data is the train data. Tingnan nyo guys ha. Using the train data, the one with 1,000, ano yan? 1,718 observations. Okay? Yun lang gagamitin natin guys. Okay, so if we run this, run natin to. Okay, meron na tayo dito guys na 3.1. Yan. Okay, 3.1, ang sabi, ano daw laman ng 3.1? Okay, it's a large binary tree. So binary tree siya, no? Okay, i-print natin yung 3.1. Okay. Print 3.1, 3.1. Okay. Medyo, guys, sabi dito, conditional inference tree with 10 terminal nodes. Okay, ibig sabihin, 10 possible na ending ng model natin. 10 terminal nodes. Tapos conditional to, conditional inference tree, where we are able to predict kung N siya, kung S siya, o kung P siya, okay, with 10 nodes. 10 yung nodes sa ilalim. Response variable natin, ito yung pinipredict natin guys, and SPF. Ang regressors natin, LB, AC, and FM, number of observations, 1718. Okay, so this will give us a, ito yung tree natin. Pero nakakalito siya, no? Nakakalito, no? 19 guys yung mga nodes. 19 nodes lahat to, and 10 terminal nodes. Okay, 10 terminal nodes yan. 6, 7, 8, 9. Okay. Okay, so medyo mahirap dito guys, mahirap maintindihan dito sa sa print, no? So what's good is that we can use the plot. Ipa-plot natin yung Tree1 natin. Okay, sige, plot natin. Yan. Then there we have guys our first decision tree. Ayan. Tingnan nyo ha. So ano nga natin to, i-maximize natin yung plot. Yan. Okay? Okay. Pause muna ako guys. Do you have the same output? Paki-check nga please kung if you have the same output. Okay, before I proceed guys, I want to make sure that all of us have the same output, no? Okay, waiting for the others, guys. Okay. Thank you so much. No? Thank you so much. Okay, now, before I proceed with this one, okay, may babalikan lang tayo, no? May babalikan lang tayo dito, yung na-generate natin dito na okay, di pala natin na no. Okay, sige, sige. Okay, wag muna. Okay, let me go back to the output. Okay. So, parang nakakalito to, no? Pero hindi. This is actually very easy to interpret. So, this looks like an inverted tree, no? Okay, ito yung roots, guys. Ito yung AC, which variable to, di ba? Ito yung number of heartbeats yata, no? AC. Okay, let me check. Okay, AC is the number of accelerations per second ng ano yata to, ng beats, something. Okay, so we have AC. And then ito guys, yung mga terminal nodes natin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sabi nga 10 terminal nodes, no? If you invert this guys, baliktarin nyo siya. So parang tree siya, no? Para siyang puno. Ito yung root, AC. And as far as we are concerned, this is the most important variable, yung AC. Okay, so how do we read this? How do we read this decision tree, no? Okay, we read this by doing this one. If AC daw is less than 0.01, kung yung value ng AC is less than 0.001, punta tayo kay LB. Okay? And then if LB is greater than 136, then ito na kagad yung decision natin. Ang decision is that if AC is less than 0.001 and LB is greater than 136, this gives us the probability of the outcome. So ito pinakamalaki guys si pinakamalaki si number 2, ano to, 'di ba? NSP. Pinakamalaki yung ano yung P guys? Yung nakalimutan ko yung P. Probable or what's our P? Wala. Nakalimutan ko, sorry guys ha. Sinulat ko dito 'yon. Potential ba? Potential. I wrote it here. Okay, sorry about that. Okay. Ayan. Sorry, NSP pala, no? Kaya pala nalito ako. NSP, suspect, no? Suspect. So balikan ko to. Okay? So ibig sabihin nito, guys, if the AC is less than 0.01, less than or equal to 0.01, and then the LB is greater than 136, suspect siya, guys. Suspect to na may problema sa heart. Suspect. Okay? Then go. Ito guys yung mga nodes, no? Yan. Ito yung mga 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then 1, 2, 3. Asan na si 4? Complete ba yung napakita sa atin dito? Okay. 1, 2, 3, walang 4. Okay. So dito guys, ito kasi 4 pala to. Sorry, tama. 19 nodes lahat, no? 19 nodes lahat. Yung iba guys, terminal nodes, yung iba decision nodes. Okay, pag sinabing decision nodes, ibig sabihin, magde-decide tayo. Yung terminal nodes guys, final yan. So all in all, there are 19 nodes of which 10 are terminal nodes. Okay, so balik tayo dito. If AC is less than 0.01, pupunta tayo kay LB. And if LB is less than 1.136, punta tayo kay FM. This is another variable. And if FM is less than 0.111, 112, then ito yung output. Tingnan natin guys, pinakamalaki yung probability na normal siya. Okay, by virtue of the probability distribution here, di ba? Okay, normal. Okay, so dito makikita natin dito, yung sa elements natin na pumasok dito, 405 lahat yun pumunta dito. Okay, ibig sabihin, less than 0.001 yung AC niya, tapos yung LB niya, less than 136, tapos yung FM niya, less than 0.112. Okay, 405 all in all. And then, what's the conclusion here? Normal yun. Normal yung state na yun. How about this one, guys, sa node 5? Again, sundan lang natin yung mga yung mga trees, no, yung mga branches, no. So yung AC less than 0.001, LB is less than 136. If FM is greater than 0.112, then ito yon. So pathologic to guys, no, pathologic. Okay, which means guys na 11 dito yung 11 yung pumasok dito. Okay, and so on guys. So if you can see guys, mas marami dito yung normal kasi nga mas malaki yung normal natin na sa train data, no? Okay, meron lang dito, ang lalabas dito yung ito yung kanina yung suspect. Ito normal yung probability dito, normal. Dito halos normal lahat no? normal, normal. Okay? All right. So once again, guys, pagbasahin natin to. If AC on the other hand is greater than 0.001, punta ulit tayo kay AC. Split ulit si AC, no? Pag si AC greater than 0.001 pero less than 0.002 siya, ibig sabihin between 0.001 and 0.002, punta tayo kay LB. No? If LB is greater than 136, then most probably normal yan. Okay? Pag greater than 136 siya, punta tayo kay FM. Okay? If FM is less than 0.012, then most probably normal siya. Pag greater than 0.012, most probably normal din siya. Pero magkakaiba yung probabilities. No? As you can see from the histograms here. Okay, pause muna ako. No? So that's how we read, guys, yung result ng decision tree. Parang inverted tree siya. So, saan natin ginagamit to? Prediction. Paano ba kung si AC ganito? So, anong gagawin natin? So, either punta tayo dito or punta tayo dito, etc. So, we can predict kung ang cartographic condition ng fetus dun sa women, okay? If it's normal or if it's suspect or if it's pathologic, ibig sabihin may sakit, no? Okay, pause muna ako, guys. Any questions about this? Yung plot ng 3.1 natin. Three so far? Okay, ang question ni okay. Pierre, can you share your question to your classmates?
Hi, sir. To clarify lang, sir.
Share mo na lang yung question mo para
Simple lang ba, sir?
kasi importante yung question mo eh. That's a very good question. Copy paste mo na lang. That's to everybody. Okay. So this is a very good question, guys, no? Ang question ni Pierre, so kasi dalawang klaseng nodes natin, di ba? May mga another name for these are temporary nodes kasi hindi pa siya final. Ang final na decision nakikita natin sa terminal node, which is node 4, 5, 6, 10, 11, 12, 14, 17, 18, 19. So all in all, there are 19 nodes, no? Of these 19 nodes, 10 are terminal nodes. Okay? Yung ibang nodes, guys, may decision nodes yan, no? May name dyan eh. Okay, ano yung nodes doon? Okay, I forgot the name, but let's call it first decision node. So magde-decide ka. Okay, for example, ito. This is a node, this is node 2. So magde-decide ka kung pupunta ka ba sa kaliwa o pupunta sa kanan. Okay, pag pumunta ka sa kaliwa, here, from my perspective, left, then you still have to go to FM, yung FM variable. And tingnan mo kung less than, again, this is a decision node. So titingnan mo kung less than 0.112 ba siya, pupunta ka dito. Dito na yung terminal node natin. Okay, ito na yung final decision natin. Okay? So you just trace the path, no? It's a matter of tracing the path in order to arrive at your conclusion. So lahat dito, guys, lahat dito, okay? If you check, if you add, guys, 405 plus 11 plus 314 plus 103 plus 7 plus 78, 18, 742, 12, at saka 28. If you add them, it would be 1718, no? It's the size of, yung sample size yun nung train natin, train data set. Okay, so let's go back here. There's another way to plot your Tree1, no? Another way to plot that is ito. Okay, we can use the type is equal to simple. Okay, so let's plot this. Control Enter. Okay, and simple yung ano niya. Okay. All right. So ito, guys, hindi histogram, ano? Numbers lang. Numbers yung pinapakita sa atin dito. Okay, so here, pareho lang din, guys, yung mga branches natin. Okay, di ba sabi natin, if the AC is less than 0.001, punta tayo sa LB. If the LB is less than 136, punta tayo kay FM. If FM is less than 0.112, terminal node tayo. Okay, so ano yung mga probability? The probability that it's normal is 71%. the probability that it's ano to? An SP suspect is 9%, and then yung hindi lang makita dito yung yung remaining. The probability is the if it's pathologic is the balance, no? Hindi lang makita. So that's around siguro mga 711, 80, siguro mga 0.2, no? 0.2 siguro yan. Okay, yung probability na yan. Okay? So dito ang advantage, makikita mo kagad yung numeric probabilities. Unlike dun sa kanina, yung hindi simple, yung plot lang, no? Makikita lang natin yung height ng mga probabilities but not the values. Of course, pwede pa natin i-adjust to, no? Hindi ko lang kabisado guys yung paano pag-adjust para makita din natin kasi hindi natin nakikita yung ibang probabilities dito. Okay, especially this. Ito hindi natin nakita yung probability nito, no? But this can be adjusted. Okay, siguro hanapin ko muna, nakalimutan ko yung paano mag-adjust ng mga width nito. Okay, but it gives us the same result, no? Only that what's given here are the quantitative values of the probabilities. Dito nga guys, 100%, no? Okay, so dito less than 0.001 yung AC, and then LB is less than 136, FM is greater than 0.112, then we're sure, 100% sure tayo dito, walang kaduda-duda na this is pathologic, 001 NSP. Okay? So yung iba may probabilities pa, no? So ito can go either medyo malapit, 57%, 43%, no? Ito 40% and 50% for suspect. No? Yung iba guys medyo malayo talaga, no? Okay? Ito 99%, 98%, 4%. So this is practically yung normal, no? Ito din practically normal. Normal din. Okay? All right. Any questions about the simple way to plot your tree? Okay, so dalawang option tayo, yung simple or yung kanina yung histogram ang pinapakita. Okay, clear so far, class?
Clear, sir.
Okay, thank you. How about the rest, guys? Okay, thank you. No more questions? All right. Okay, so now we can actually modify the model. Kasi kanina, 19 nodes tayo tapos 10 terminal nodes, di ba? Pwede nating i-split yung model, baguhin pa. Okay? We call that pruning, no? Pruning the tree. Kasi kunyari, lalo na kung maraming variables, no? Kung maraming variables, tatlo lang ginamit natin eh. Tapos tatlo yung terminal nodes natin. So, maybe that can be very unwieldy yung model na yon. But of course, guys, ang advantage yun, talagang mas masinsin yung model natin, no? Kaysa yung pag konti lang, guys, konti lang yung branches natin, konti lang yung nodes natin, then we can say that it might be less accurate kasi mas malaki yung range na tinitingnan natin, okay? So if you want that, we can use ito yung there's a function dito sa guys sa model natin, okay? So we can use controls, no? Dito. So C3 pa rin tayo, classification tree, then isasama natin yung controls. Okay, ang code natin dito, controls is equal to classification tree underscore control. Pwede natin i-include yung minimum criterion at saka yung minimum split. Okay, ano yung minimum criterion? Okay, sa minimum criterion, guys, pwede natin gawin kunyari 0.9. Ibig sabihin ng 0.9, guys, yung confidence level natin. Okay, pag mas mababa yan, kasi ang default yan 0.95 kanina, di ba? Pag mas mababa yan, ibig sabihin mas maraming pwedeng ipasok dun sa criteria natin. So, pwedeng mas lumiit yung yung nodes natin. Okay, and then here, minimum split. Ano tong minimum split na to? Okay, branch will split into 2 only when the sample size is at least 200. Okay, so naglalagay tayo dito ng, once again, ng control para hindi lang basta-basta na mag-split yung data natin. Dapat minimum 200 bago siya mag-split into 2. Okay, let's try to run this. No? Okay, so we're naming this tree 1A. So parang ano siya, parang variation ng Tree1 natin. Okay, then i-print din natin siya. Okay, tapos plot din, and then hanggang dito muna sa plot. Tingnan natin what happens. Control Enter. Okay, so ito nabawasan yung terminal nodes natin, ano? Kasi kanina 10 eh. Ito ang terminal nodes natin. Ang terminal nodes natin naging 9 na lang, no? It became 9. So nabawasan yung mga basket natin kung saan papasok yung kung normal ba o suspect o pathologic, no? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So nabago siya. And na-notice din natin, mas kumonti lang yung mga ano natin, yung mga nodes natin. In fact, ano na lang, no? 17, yeah? It's 17 na lang. Kanina 19, of which 10 were terminal nodes. Dito, 1, 2, 3, 4, 5, 6, 7, 8, 9 na lang, no? 9 na lang. So mas lumalawak nito yung ano, yung model natin, no? Okay, so mas kumukonti yung mga splits natin. Okay, because we included yung minimum criterion na 200. Hindi siya pwedeng mag-split ng ano ng hindi siya pwedeng mag-split unless yung minimum na laman ng mga branches na to is 200. Okay, so same interpretation, guys. Okay, same interpretation. Okay, ganun din. All right? Okay, so if we plot this, ito naman gamitin natin, guys, yung simple naman. Pareho lang yan, guys. Same thing. So we now have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 din yung nodes natin. As compared to the first model natin kanina na 10 yung nodes natin. Okay? Alright. Then, okay, another example, guys, ng ipo-prune natin yung tree. How about this? Okay. Gawin natin ang minimum criteria natin, 99, tapos split tree natin, kanyari 300. So the more we increase the minimum split, the lesser will be the nodes, no, that will be generated. So if we run this, i-action muna to, guys. Nabigay ko na sa inyo, nabigay ko sa inyo, na-run ko na, okay? And then i-run natin. Okay, so ito yung result, no? Okay, let's take a look at this one. Yung last, yung simple. So 1, 2, 3, 4, 5, 6. 6 na lang, no? 6 na lang yung nodes natin. Okay, so 11 nodes, of which 6 are terminal nodes, the others are decision nodes. Okay, so we can, ang tawag dyan, pruning the tree. Okay, kasi kanina mukhang madami, and if you feel that di naman kailangan ng ganun kadami, you can prune the tree by including yung control, no? Yung control measures natin. Okay, so let me just close this. Okay, questions dito, guys? Siguro pag 500 natin, try lang natin, ha? Kung i-500 natin to, what will happen? 500, and then i-run na natin lahat. Okay. 5 na lang, no? Kanina 6 eh. Okay, so the more we increase the minimum size, the lesser will be your nodes. Okay, your terminal nodes. Okay. Okay, paki-close nga nito, guys, kasi I think nabigay ko sa inyo yung na-run ko na kanina. I was trying to run this a while ago. Pati ito, paki-close nyo muna yung may mga answers na kasi tayong gagawa ng answer na yan. Okay, wala na. Ito pa pala. Paki-close nyo yan. Kasi iraran naman natin yan. Okay, so let's see how far we can go. Meron tayong 7 minutes. No? Okay, now as I said a while ago, guys, saan ginagamit tong saan ginagamit tong decision tree na to? Tapos ba tayo nag-split ng data? So sabi natin, yung split data natin, yung isa ginagamit natin to model, And then yung isa, ang gagawin natin, check natin kung using new data, kung okay ba yung model natin. Okay, first guys, we have to, ang gawin natin, i-predict muna natin, okay? Testing, ano ba yung 1B natin? Okay? So itong 1B natin, di ba, ano to? Ito yung, balik natin sa 300 para pare-pareho tayo. So this is the one with a minimum criterion of 90. Gawin natin 95% na lang para, okay, 95% tapos 300. Okay, if you can see here, 1, 2, 3, 4, 5, 6, 7, 8 yung ano natin, 8 yung terminal nodes natin, ano? We have 8 terminal nodes, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 terminal nodes. Okay, so what we're going to do is we're going to use that model in order to predict. Okay, i-predict natin. So let me cross this. Okay. So ang gagamitin naman natin ng model guys, yung 3.1b, ito. No? Okay, where you have minimum criterion of 95%, okay, and minimum split of 300. Okay. Now, we'll create now, itatest natin yung 3.1b natin, okay? I-run ulit natin sa, okay, sa train data set natin, okay? So di ba may model tayo? Ang model natin yung 3.1b. Iko-compare natin guys yung result ng model natin dun sa actual value. Okay? So ito, tingnan nyo ha. We'll call it P1, okay? And this is yung sa train natin. Predict natin using yung 3.1b natin. And then compare natin yan sa train data natin. No? Okay, so let's run this. Okay, what do we have here? Run ko ulit to. Okay. Hindi pa rin pumasya. Okay. So what do you have here? For 1, guys, for 1, we predicted that it will be, ang prediction natin, si NSPF, no? Diba? 2 siya, no? Okay? Ano ba yung actual niya? Ang actual niya, guys, ito, diba? Yung 2. So dito, guys, mapipredict natin, we use the predict function in order to determine ano ba yung naging predicted values natin ni NSPF, tapos ano yung naging actual value niya. Okay? So is that clear, guys? Clear ba yung concept na yon? So itong head lang natin, head ng, okay, sorry about that. Ito head ng train natin, no? Head ng train data natin. This is the actual, no? Kasi yung train data natin, actual data yan, di ba? Okay, so what did we create? P1T. Ano yung P1T? So let's go here. What's P1T? Ito. No? P1T is a factor with 3 levels. I-click na natin to, guys. Okay, medyo matagal, no? Okay, so while it's waiting, guys, here, okay, wait, my question. Print ko nga si P1T. Okay. So what's this P1T, guys? Let's see kung view natin to. Okay. All right. Ito si P1T. Sino ba si P1T, guys? Si P1T is our predicted value. No? predicted value natin yan. Okay, so sabi natin, i-predict ko nga using the model 3.1b, okay, and predict the train data. No? So ginamit niya si train data and use the 3.1b model to predict it. Tapos ito yung lumalabas. No? Ito yung lumalabas. So if we compare guys, 1, 1, 1, yung first ano dito, first 9, 1 siya lahat. No? Ito yung predicted value. Yung 10 and 11, panay 2. Tingnan nga natin yung actual data. Okay. Si actual data natin guys, yun nyo. 2, 1, 1, 3, 3, 3. So what does that say about our model guys? Ibig sabihin may mga errors tayo, may mga na-miss out tayo, may mga maling prediction. Kasi based on the predict value, sabi niya, si observation 1 dapat yan 1. Pero when we looked at the actual value, si train 1, the actual value was 2, no? Tapos in fact, si actual value ni 6 is 3. 6 and 7 is actually 3. 3, 3. Pero pagdating natin sa predicted value, 6 and 7 is 1, 1. Okay, so we know that there are errors, guys. Hindi 100% proof yung model natin. Okay, so we would like to know kung ilang percent yung ano natin, yung error natin sa model natin. No? Okay, so how do we now compute for the errors natin dun sa table 1 point. Okay, so dapat to. Okay, so 1 point B natin to, no? We use the 1 point B. Okay, so let's take a look at this, no? So here we're creating an object called tab.1a. Okay, object to, no? And it's supposed to be a table. Okay, ano laman ng table nito? So here we have the title predicted, and the predicted is equal to yung predict ng 3.1b, no? Yung dito kanina, no? Tapos yung actual niya will be equal to sa train data natin yung NSPF. So dito guys, kino-compare natin yung predicted value ito and also the actual which is equal to train NSPF. Asan ba yung train natin? Ito. Okay? So isa side by side natin siya. Gagawin natin siya ng table, no? Okay, time na pala guys. Tapusin ko lang to guys ha. Okay. Table guys, you have two columns here. Yung una will be the predicted value. Pangalawa will be the train value, no? Yung actual value. So i-print natin to. Okay, let's run this to tab 1A. Okay, careful lang tayo, no? Ito 3.1b, ito yung model natin. So ang table natin 1A. Okay, pangalan lang naman yan. Okay, control enter. All right, look at this guys. Okay, ito na yung ano natin guys. Ito yung predicted value natin, ito yung actual value natin. So this is saying that, guys, may I have one last minute? Okay lang ba? It's already time, 4 o'clock na. Permission guys for one or 2 minutes just to summarize this.
Yes, sir.
Okay, thank you. Thank you. All right, take a look at this. Ito yung mga predicted natin. So predict ng model natin na 1, 2, 2 guys will be normal. And it turned out that this was normal. So tama ito, no? Okay, predict niya na normal, pero actually hindi siya normal. Number 2 siya yung actual. It was suspect. Tapos predict niya na normal, pero mali. It was pathologic. So makikita natin dito guys yung mga errors, no? Yung mga tama dito yung diagonals. Kasi predict niya na 2, tapos tama nga, 2 nga siya. No? Suspect nga siya. Ito predict niya na 3, okay? 11, pathologic, tama nga na pathologic siya. So the diagonals are the correct values, the others, the off diagonals are the wrong values. So sa prediction na sa pathologic, wala siyang mali, no? Pero may mali siya sa pag-predict niya kay, okay? May mali siya sa pag-predict niya kay number 2, no? 126 ang predict niya. Ang actual niyan dapat suspect yan, pero predict niya na normal. So 126 is wrong. 156 is correct, 32 is wrong. No? So yung mga wala sa diagonals, guys, those are the wrong predictions. The ones that are in the diagonals are the correct. Okay, so how do we compute, guys, for the correct predictions? Madali lang yan, no? So ang gagawin natin, guys, remember itong object na to, ang pangalan niyan tab1.a, no? Tab.1a. So isa-sum up natin lahat ng mga diagonals ito yung function, sum ng diagonals ng tab.1a divided by sum ng total, no? Sum ng total dun sa table 1.a. So kunin natin to. So that's the correct values divided by the total values. So that's 81%. So therefore, yung wrong predictions natin is simply 1 minus your correct values. This one. There. Okay, sabay natin sabay-sabay natin i-print. Okay, ito na lang. Okay, para isang table. Yan, no? Okay, so you have here the table of predictions versus the actual. The correct one is 81%, the wrong one is 19%. Okay, so ito yung model natin. So this is decision tree in classifying NSP, NSP, no? Kung magiging normal ba, kung normal ba yung yung heart rate, yung baby, yung fetus, yung suspect or pathologic kung may sakit. Okay? So next meeting, guys, we'll continue with this. Tatapusin natin to, no? We're going to finish this, everything here. Okay? Ito, guys, paki-download na yung panibagong may isa pang package na gagamitin natin, si RPart, no? Okay, iba din to, no? This is also used for decision tree. Paki-download si RPart. We'll finish this next meeting and then we'll go on to another example ng decision tree. So, in the first few sessions, decision tree muna tayo, tapos pupunta tayo sa random forest, etc. Okay? So, I hope you learned something today, guys. Okay, sure, Pierre, you can stay. All right, maraming salamat, guys. I'll stop recording first.